Yeah. So good evening, everyone. This is Samarth, and since the past few weeks, we are covering topics into differentiation and integration. So we'll be continuing doing that, and we have the new topic with us that is differential equation, and we'll see what are we covering under differential equation. So basically, we'll try to cover the what basically a differential equation is and what does it look like, what is the order and degree of a differential equation. Also, guys, I think I'll try to say differential equation as maximum as possible, but I have a habit of saying it DE. So I think it is more efficient way of saying the differential equation because we'll be saying it quite often. So let's shorten it to DE. So the order and range of a DES and formation of a DE ordinary differential equations, that is ODE, we'll also study about. Then what is the solution of a differential equation, methods of solving an ODE, real-time applications of differential equation, right? So yes, coming to the main part of it, what is the differential equation? Yeah, what are differential equations? So see, we'll take a real life approach to it first, that where is its application and how does it look like. So see, there are various models that works on differential equation, and one of them is like population increase, because there is always a factor that is included in in the equation of a population increase, be it chemical change of some kind, location or locus of football. These are all real life examples. So let's see the mathematical definition of what a differential equation looks like. So a mathematical equation that relates a function with its derivative is called a differential equation. It's as simple as that. That a equation, when linked with its derivatives, is a differential equation. For example, d is equals to x dy by dx. It is a differential equation because it is giving me a relation, excuse me. So it is giving me a relation between y, the function, and its derivative, right? So this is a differential equation in itself. The function usually represents physical quantities, derivative represents its rate of change. Differential equation defines a relationship between the two. Yes, that is what we studied. So history, we can take a bit of history, but it's not necessarily for JEE-Mains, but we should be able to like understand where is the origin and how does it come about. So in mathematics, the mathematics history of like we'll just read it through once and see what does it say. So in mathematics, history of differential equation traces the development of differential equation form calculus itself, independently invented by English versus Isaac Newton and German mathematician Gottfried Leibniz. The history of the subject of differential equation in concise form, a synopsis of the recent article, The History of Differential Equation from 1670 to 1950. Okay. So this was a bit of history. So let's move on and just fresh up what we studied in the last class and how can we like put it into differential equations. So we know what does a slope look like. So slope is change in y divided by change in x, right? So this is the basically what we define as slope. Yeah. So coming back to differential equation, that was just give you idea of what does a differentiation look like. A differential equation is an equation with a function and one or more of its derivative. Okay. So see, we did an example back then, right? So this is also an example of a differential equation because here we are linking dy by dx with its function y. Again, we can see further examples of what does a differential equation looks like. Yes, this is we understand why first two are differential equations, but when you see the third part, you see there is not a differential function that we see. It's simply the equation is d square plus there is no dy by dx in the equation, right? So therefore, it's not a differential equation. And this is also not a differential equation because there is not an equal to sign. Yes. The formation of differential equations. So as we are aware that the family of straight lines is represented by y is equals to mx, yes, passing through 0 comma 0 because it is not all straight lines. Yes, it's easily understandable. And this is the differential equation of first order. So we'll understand what does order and what does degree mean of a differential equation in further slides. Formation of differential equation. Okay, so we have a is equals to, sorry, y is equals to a cos x plus b, where a and b are arbitrary constants. Dy by dx is equals to minus a sine x plus b. Okay, and d square y upon dx square. Okay. So we know we can write a differential form of the equation. This is the differential form, if you can see. Yes, now getting to order and degree, what does an order and degree look like for a differential function? Okay, so order is basically the highest power of the derivative. Like, what is the highest derivative we have in the equation? If we have we have a double derivative and a triple derivative. So the highest order would be 3. Right? It won't be double, but if there is not any other highest derivative available and only there is a double derivative, then the order would be 2. Now, getting back to degree, degree is the highest power of x, the independent variable. Whatever is the highest power of the independent variable, that is our degree. We can look into some examples. For example, here dy by dx plus y square is equals to 5x. So dy by dx is the single derivative, right? So the order would be 1. Here the order would be 2 because there is a double derivative present. Here there's a triple. So it is 3. Oh, I think there is a mishap. So degree is being called as the highest power of the derivative. So it is not the highest power of the independent variable as I stated earlier. It is the highest power of the high, it is the power of the highest or like differential. Okay, so now we move on to how do we solve a differential equation. So basically, the solution of a differential equation is basically an equation between the variables without the differential itself. Yes. So, for example, if y is equals to a cos x plus b sine minus b sine x, so this could be a probable solution, right? Like we can talk about general solutions and arbitrary solutions. These are not like too much to be talked about. So let's move on to the questions and answers part of it. Let's see how do we see about. I think we also didn't cover the standard D, right? Just a minute, guys. I'll just pause my share and include the standard D part here. Just a minute. Just give me one more minute. I'll just add the standard D part and we'll move on to that. Okay. So here is the part that I wanted to talk about. Let's see what does it say. Yeah, so this is the NCRT and we look out the topic that we missed while discussing differential equations. So let's see. We discussed what an order and degree look like, right? The highest, yeah, we did this. Now general and particular solution of a differential equation. So we know that these are the two types of equations and the solution of equation one are numbers that will satisfy the given equation when a number is substituted for the unknown x, the given, okay, fine. Now considering the differential equation this, in contrast to the first equation, the solution is a differential equation of this differential equation is a function phi that will satisfy it. When the function is substituted for the unknown y independent variable is given differential equation phi. So basically what we're trying to do here is we get that the solution of a differential equation is a function itself. And it could be a general function or accurate function. General function is a function where the variables are not defined, they're arbitrary. For example, here, what we are trying to do here is it's of the function given to us is y is equals to a cos x plus b sin x. So here a and b are arbitrary and can take any values. But in the case of this, we know that function is e to the power minus 3x. So we cannot change this function according to ourselves, right? So it's a particular solution. Okay, just give me a minute. There is a siren outside. I'll continue speaking. Let's try doing some questions and see how does it go about, right? Let me just do some questions and then we'll see how does it flow. So, okay. First, we have the differential equation representing the family of curves is C is a positive parameter is of which? So what do? We try to remove the arbitrary parameter here, right? So we'll try to remove that first. Let's see how do we approach the solution to the best possible way. Yes, we have this and we differentiate it, right? So we get this. So we eliminate C and write this equation here. and we clearly get what the order and degree is. Okay, so we'll try to solve it by ourselves also and see how does it flow about. So we were given y square is equals to 2c into x root c. So 2y dash is equals to 2c. So we get the value of c directly and we substitute it here. So again, we have the highest derivative as y dash. So the order becomes 1 and the degree becomes 3 by 2. Let us see the solution. It says A is the solution. Okay, it's order 1 and degree 3 by 2. For any differentiable function, y is equal to fx, the value of this is. Let's see the solution and move on. Okay, so we are aware this is available for any differential quotient. Okay, so we are differentiating the whole part with dy by dx. Okay. Okay, so this is the solution that we have. You guys can see it. So what we did was we tried to differentiate this part with d by dx again. So what we got was we take dx by dy as a function itself. Okay. Let's move on to the third part. Let's see what the solution says for question number 3. I hope you guys must have read the question. Okay. So what they're trying to do here is we have taken cos theta as a constant here and try to integrate it. So this might be including integration as well. And I know that we have not covered integration right now. So we'll skip this question and move towards the next part. Okay. Next part we have here is that question number 4. If y is equals to 4x plus 2 into e to the power minus x satisfy the relation this, then the value of a and b respectively are. So let's do this. Let's differentiate and see how does it go about. So dy by dx is equals to 4 e to the power ex. Okay. Double differentiating. Now differentiating it again. This is what the derivatives look like, and we put them in the equation. right? So let's see what does it give us. So we collect the values of e to the power 4x and e to the power minus x. We have 64 plus 4a plus b. And at this we have minus 2a plus 2a. Sorry, 2b. So these should be equal to 0. Okay, so now let's see what we can do here. Let's multiply this by 2 and add it with this. Now, so b is minus 12. Negative 13. Negative 13 and negative 12. B. So what we did was, since the whole equation was equal to 0, then the coefficient would go to 0 because e to the power something would never go to 0, right? So the solution is yes. Let's move to the fifth part. If fx and gx be twice differentiable function on 0 to 2 satisfying f double dash sorry for that, f double dash x is equals to g double dash x and f dash 1 is equals to 4, g dash of 1 is equals to 6. Okay, so what is required for us to find out? So let me raise it a bit and get back to the question. So this is the question and we have to find f of 4 minus g of 4. Let us see how do we go about the solution because it's not clicking to me right now, but we'll see. Okay, so we are moving with this equation forward. Great. So we have a value of c, then we integrate it again, and then we get a function of f of g together. Yes, that's a cool way to move about. Yes, very efficiently done. It was a direct method, nothing new. We simply went with the first equation went by and started integrating. Cool. Let's move to the another equation we have for any differential function y is equals to fx. The value of d, we just did this question, right? This was equal to 0. Yes. Sixth has the answer of A. This is the very same question that we did earlier. Let's move on to seventh. So axis of a parabola is this, right? So it is an axis is this. So what would the parabola's family look like? You get what do we mean by axis here, right? Okay, so it would look like as this is what the equation would look like. Of all the parabolas which are having their axis as y square. Oh, sorry, as x axis. So now we have to find degree and order, right? So let's differentiate. Now we substitute the value. And we can add the value of a of as well. No, we cannot put the value of a here. Let me check once. Let us go to seventh part and see how they're going about to the solution. This is very similar to what we did. Okay, so what they've done is they try to derive it and put the values of y here. So we get the squares out and we have to double differentiate it, right? Because there are two arbitrary variables here. So there has to be an automatic double derivation to take place. Let's move to the eighth question. So the differential equation, okay, it is very easy. This is the equation of our ellipses that are centered at the origin. So let's derivate it. Yes, this is what the equation looks like. We derivative it. Differentiating again, okay. Yes, so we get the variables out. The thing is, here you can see also again, there is a double derivative because there are two arbitrary variables. So there is no thought of checking that if there would be a double derivative or not. Double derivative would be always present in the equation if the number of variables are more than one and equal to two. Right? So the derivative, the highest power of derivative is often equal to the number of arbitrary variables present in the equation. That is how we roll about in the questions. Okay, so now, okay, so now we have another question. Let's go with question number 9. The particular solution which passes to 0, comma 4. So it is very easy. We are given dy by dx is equals to x minus 3y plus x. So what we do here is we take x as common and we write dy by dx 1 minus 3y is equals to x dx, then integrated. We get ln of 1 minus 3y divided by 3 is equals to x square by 2 plus c. We take the value 0, comma 4. But since it cannot, ln cannot take a negative value, so we'll have to change this up. And how would we go about that? Let's see. So we'll do one magic trick here while integrating. We'll write dy by dx take the negative out and write 3y minus 1 is equals to x dx. And now integrated. So ln of 3y minus 1, 3, sorry, divided by 3 x squared 2 by c. So what do we do here? Now we put the value. So x is 0, so c's values is 12 minus 1 is 11, ln 11 by 3, right? So this is the equation that we have. Let me erase it, the sum of these things, and then we'll write the accurate equation. Okay, so the equation that we had was, we got the value of c of this, right? So the equation we had was ln of, so what we do is, we take it here. We have, no, let's take this here. So ln 11 by 3 minus ln of whole by 3 is equals to x square by 2. Let's send the 2 there, the 3 there. So we are left with ln of 11 by 3y minus 1 is equals to 3x square by 2. And 11 by 3y minus 1 is equals to e to the power 3x square by 2. Do we have 3x square by 2? Yes. So I think we have option between this and this. So it is 3y minus 1, right? There would be a minus sign. So A is the answer. Guys, I'm trying to show you how do we solve during examinations because it's a very fast process and you have to think really quick while solving. So as you can see, what we did was we tried to integrate the equations and put the values of y and x to get the value of c, and eventually putting the value of c and solving it further to get a standard equation. Okay, so now taking this equation into consideration, the easiest way we can simply take the solutions and differentiate it once. That would be really easy and good, really fast answers. But there is another way as well. Let's see how the invigilator, the examiner went about. Okay, so we had dy by dx is equals to y by x plus tan of y by x, right? So we take yeah, this is the usual formation, like this is the kind of questions where y is divided by x. So what we do is we take y is equals to v of x, which gives us fluidity while solving questions and makes our questions very easy to solve. So if we take y is equals to v by x, what we get is dy by dx, we'll write that, like v is an independent variable here, right? We cannot take v as a dependent variable here. So v would be an independent variable. So dy by dx would look like v v plus x dv by dx. Okay. And then the other part would look like v plus tan v. Now it gets easily integrable and we get the value and see what the correct answer is. Okay, so let us see how much time we have left. We have ample of time left now. We have 15 minutes, right? So let's see. Let's go through with another question. Let's do 11 question and we'll do this by ourselves now. So the thing that we have here is 11th question, right? The degree and order of the differential equation of all tangent lines to the parabola x square minus 4x. Okay. Just a minute, guys. Just give me a minute. I'll be back. Give Okay, so back to the question as we were discussing this. So we were discussing the order and degree of the differential function, right? So what is the equation of a tangent line? So the standard parameter of a point here looks like, so y is t square here, and this is 2t. So these are the parametric equations of the parabola here, and a tangent line would pass through these equations, this point. So a line passing through these points can be y minus t square is equals to m into x minus 2t. Here, m and t are arbitrary, right? So let's differentiate it and get the values out. Let me see how does it the problem go about. We'll see and go through the solution by itself. Okay. So are we right about the equation? Yes. They have taken the value of t and m here. So they have only a m as arbitrary constant, but we had two arbitrary. So how could we remove one more arbitrary there? Let me see. Okay, so this would not occur. I'll tell you why. Because we have a standard slope for a parameter t, right? So there is a formula there. Let's see how the solution is being done and we'll see how we can go about it. Okay, so what we have here is, okay, the standard equation of a tangent to a parabola standard as x square is equals to 4y. So this is the standard the equation of tangent, and then we try to remove the arbitrary constant here. And what the equation we get here is this. So since here the highest differential is of 1, so the order is 1, and the highest power of this differential is 2, so the degree becomes 2. Okay, now moving to the next question. What we have here is, this question we did, right? It was minus 13 and minus 12. This was already done. This is already done in the previous session. Let's do this one. This looks nice. So what we can do here is we can write x by y dy by dx is equals to log of y by x plus 1. Okay. And since we can see a lot of y by x on this, so we'll take y is equals to vx. So we are left with 1 by v plus x dv by dx is equals to log of v plus 1. This gives us 1 x plus v dv by dx is equals to ln v plus 1. So 1 and 1 gets cancelled. We have x by v dv by dx is equals to ln v. Okay. So what we have here is dv by v ln v is equals to dx by x. Now we integrate it. So we take ln v is equals to t. So we have 1 by v dv is equals to dt. So this becomes dt by t is equals to ln x plus c. So this is ln t, and t was ln v. So ln of v is equals to ln x plus c. So we can write it as ln v is equals to kx. K is again another variable. And then we have v is equals to e to the power kx. And v was our y by x. So y by x is equals to e to the power kx.
So y becomes x e to the power kx, where kx is an arbitrary constant, x kx. So I think we were done here only. I don't think there is this is the right answer, guys. This ln of y by x is equals to kx. Ln of y by x is equals to kx. Ln of y by x is equals to cx or kx. D. 15 gives me answer of D. Let us check. Yes, D is the correct answer. Let's move on to the next question. Let's do something easy right now because since we have less time left. No, we don't have much time left, guys. I think we'll have to wrap it up. But this is like the kind of questions that usually come in JEE-Mains and advanced, and you can easily crack it. Differential equation can be a tough topic, but when you like practice it thoroughly and see the different methods of solving questions, you will see that it is not that tough of a tough topic. So I'll leave it with you this and hope you practice more and be able to solve the questions. Also, if you have any doubts, please you can comment down. I'll try to solve and answer back. So thanks.